Welcome back to another video of Math Times Cool. In this video, I will be proving theorems about triangles. So let's begin, or using similarity. Okay, let's begin. So a line parallel to one side of a triangle divides the other two proportionally. So let's begin with that. So let's say you have two triangles, right? And you're told that one side is parallel. You know that these two triangles are similar because you know that these two angles are congruent because they're corresponding, and these angles are congruent because they're corresponding. And you can prove that they're similar using angle. So we can prove that they're similar using angle because I explained it in a different video, so make sure to watch that. Anyway, so we have these two parallel lines, right? And then they're cut by this transversal, right? So let me grab that. You can twist this, right? You can twist it. You can see that this, whoops. So you can see that you can see that this angle is to that angle, which it would be this, wait. So you have this. So I just flipped it around, so it would be this and that, these two. And if you just flip it, it would be like that. And again, you have these two parallel lines, and then this. Then you can see that these two are congruent. Okay. Yeah. Anyway. So now we've proved that they're similar using angle, right? And then so now we can say that a line parallel to one side of a triangle divides the other two proportionally. So we can say that that this over the whole length is equal to this over the whole length because corresponding parts of similar triangles are proportionate. So yeah. So bang, we proved that. Now let's do the other theorem. So the Pythagorean Theorem proved using triangle similarity. So we will use this diagram. So we have a triangle. So this triangle inside of a circle that's split into other triangles. So, oops, let me just delete this. Okay. Now let's begin. So we have to prove that a squared plus b squared is equal to c squared. Okay. So this is what we're trying to prove. So let's first do let's first do the proportions. So we know that BD over AD is equal to AD over DE. Because as we can see, so this is DE, and this is A. Now this would be B because you flipped it, and this would be A, and this would be D. So these would both be right angles, right? You also know that when you have a bisector coming straight down, you know that these two triangles are parallel. And then so you know that because I proved this theorem in a previous video, so make sure to watch that video too, because I explained why they are parallel. Okay, so now let's continue. Okay, I just noticed something. So we can also prove that oh wait, never mind. Okay, anyway. Gosh, okay, anyway, let's begin. So let's actually no, it came back to me. Okay. So we know that let's say this is x, right? Let's say that's x. This is we'll name this A and this A because they're right angles, so they're both congruent. And then we know that this is Z, so this angle is Z, and this angle is T, right? Let's name that angle T. Okay, so we know that 180 minus A minus X is equal to Z, right? So, and then we also know that 180 minus A, let's name this F minus F is equal to Z, is equal to T. This is equal to Z, right? So we can see that these two are the same, right? So let's name, so we know that A is 90 degrees, so 180 minus 90, right? 90. Let's say X was 60 minus 60, Z would be 30, right? Since this is 60 and we have this, so we know that that's 30, we know that this is 90. 150, 180, right? We know that this is 90. We know that this has to be 62 because you can see that this is right on the diameter. So this would have to be half of this arc, and this is 180 divided by 2 is 90. So this would have to be 90, so that would have to be 60, and then this would have to be 30. So they're ultimately, so this is another way of proving that they're similar. So we know that they are similar, right? So we know that it's BD to AD, and AD this over DE. Okay, so now let's name AD as B. So let's give them values. So B over, and then BD is just C plus A, right? Because we have this other point drawn, so this is C plus A, it's BD. And then since C is the radius, we can find DE as C minus A. So C minus A. Okay. Now again, or now you can just multiply by B and C minus A, so that would be B squared equaling C plus A, C minus A. So I covered this in my Kumon video, so make sure to check that out. So as you know, you distribute the C, so it'd be C squared. Then it would be C squared, and you distribute the C again for the A, so it'd be C squared minus AC plus AC minus A squared. Because again, A times C is positive AC, and then A times negative A is negative AC. And then so you can see that these two cancel out, so it's just C squared minus A squared is equal to B squared. And then when you add A squared, you get C squared is equal to A squared plus B squared. So you have successfully proven that that these two triangles are similar, or that you proved that you proved the Pythagorean Theorem using similarity. Good job. So I hope you enjoyed this video. Make sure to watch my other videos. Sorry for not being able to upload frequently over the past week, but don't worry, I'll get back to uploading every single day from now on. So yeah, I will be uploading another Kumon video probably Tuesday, probably either tomorrow or the day after, because this video will be uploaded on the 12th. So thank you for watching, and goodbye.